Hey everyone, good morning. I am Priyanshu Iqbal and welcome back to my YouTube channel. Now we are going to see the first question of today's weekly contest 450, which is smallest index with digit sum equal to index. Okay, so let's see what is this question and how we can solve it. So in this question we are given an integer array nums. Return the smallest index I such that the sum of the digits of nums I is equals to I. Okay, and if no such index exists, you need to return -1. So in this question, you have been given with an array nums, and you need to return the smallest index I such that the sum of the digits of nums I is equals to I. Okay, so let's see. So let's index this 0, 1, 2. The sum of digit is 1, sum of digit is 3, sum of digit is 2. So is 0 equals to 1? No. Is the index equals to digit sum? No. Index equals to digit sum? Yes. So you need to return the smallest index such that the sum of digit equals to num size. So here sum of digits is equals to index. So you need to return this index. So its output is 2. Okay, let's check for another test case. Let's index is 0, 1, 2. Sum of digit is 1, 1 and 2. 0 equals to 1? No. 1 equals to 1? Yeah, so you will return 1. Here 2 is also equals to 2. But you need to return the smallest index. So that's why we will return 1. Okay, let's check for another test case as well. This index is 0, 1, 2. Let's find the digit sum. It's 1, it's 2, it's 3. 0 equals to 1? No. 1 equals to 2? No. 2 equals to 3? No. It means there doesn't exist any number which has index equals to digit sum. So what we will do? We will simply return -1. So what we need to do in this question, we need to basically get the digit sum of all of these numbers and check whether digit sum is equals to index or not. If yes, then we will simply return that index. Okay, so how we will get the digit sum? Okay, so let's consider some number 432. So how we will get the digit sum of this number? So let's say we will start a loop till n is greater than 0. Okay, and we will initialize sum as 0 initially, and we will add n modulo 10 in our sum. And what n modulo 10 will give us? N modulo 10 will give the last digit of that number. Okay, so now sum will become 2. And now again, but we have to do something with n, otherwise we will keep on getting 2 and 2 again and again. Okay, so how we will update n? We will update n in the way that n is equals to n by 10. So that now new n will be 43, right? Okay, now n is still greater than 0. So sum plus is equals to n modulo 10, which is 3. So 2 plus 3. Now n will get updated to n by 10, which will be now 4, right? Now n is still greater than 0. So sum plus is equals to n modulo 10, which is 4 now. So plus 4. And now n is equals to n by 10, which will be now 0. So is it greater than 0? No. So we will simply came out of this loop and we have got our sum as 5 plus 4, 9. And the digit sum is 9. Right? So in this way we can get the digit sum of all the numbers and check whether that digit sum is equals to the index or not. And if yes, then we simply return the smallest index. Okay, let's try code this. So what we need to do, we need to keep on iterating on this vector I is less than nums dot size I plus plus. If digit sum of nums of I is equals to I, what we will do, we will simply return I, otherwise -1. Now let's declare that digit sum function as well. Digit sum int n int sum is equals to 0 while n is greater than 0. If what we need to do, we will need to update sum with n modulo 10 and n is equals to n by 10, and we will return sum. Let's try run this. It's working fine. Let's try submitting it. Yeah, it's working fine. So now let's talk about its time and space complexity as well. So its time complexity will be big of n, as we are doing this one iteration, and then we are also doing this digit sum iteration every time. But how many times this loop will run? This loop will run the number of digits. How many number of digits are there in a that much times this loop will run, execute, right? Okay, so let's see how many digits can be there in a number. It can be up to maximum of 3, right? As n is, as nums of I is less than or equals to 1000. So it can be maximum up to 3. So it will be 3n maximum, or we can say that big O of n. And do we have used any extra space? No, we haven't used any extra space. So its space complexity will be big O of 1. So yeah, that's all for this question. It was a pretty simple question as this was the first question of the contest. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.